Hello student, good afternoon. Today we will start the next topic, that is fertilization of chick. Fertilization in chick. Fertilization is internal in hen and occurs in the upper part of the oviduct. Before the deposition of albumin among the egg cell or ovum. Here the egg cell or the secondary oocyte becomes surrounded by the several sperms. Several sperms enters the oocyte polyspermy, but the nucleus of only one sperm fuses with the nucleus of the oocyte. Nuclei of the other sperm degenerated. The penetration of sperms into the oocyte, includes it begin a complete the second maturation division as a result. A second polar body is extruded from the ovum. Next, after fertilization, cleavage or segmentation is start. In this, the process of cleavage is equal but incomplete, and cleavage furrows are restricted to the germinal disc or blastodisc. It is called discoidal meroblastic cleavage or simple meroblastic cleavage. The first cleavage furrow consists of slight meridional incision near the center of the germinal disc. This furrow passes yolkward but does not reach the lower portion of the disc where the cytoplasm is filled with coarse yolk granules. The second cleavage plane is again meridional but at the right angles to the first. The third set of cleavage furrows is vertical, cutting across the second set of meridional furrow and consequently tends to parallel the first cleavage furrow. The fourth set of cleavage furrow is also vertical, and although not synchronous, but it proceeds gradually to form 8 central blastomeres, which are surrounded by 12 marginal blastomeres. Thus, the meridional and vertical cleavage separate the daughter blastomeres from each other, but not from the yolk. In a later stage of cleavage, the blastomeres of the central area become separated from the underlying yolk by horizontal planes of fission. Thus, in later stages of cleavage, the central cells of the blastodisc becomes cut off on all sides, but for some time at the edge, edge, the periblast. There is syncytial region where cells still remains in open communication. Further cleavage produces a blastoderm, a round disc 5 to 6 cells deep in the center but only 1 to 2 cells deep at the periphery. The blastoderm contains formative or embryonic cells which later on form the embryo proper. Very soon a subgerminal space or cavity, also called segmentation cavity, is formed only under the central blastomeres and is thought to be originated due to accumulation of fluid from the albumin through the vitelline membrane. This cavity separates the yolk from the overlying blastomeres or of blastoderm. As the development progresses, cleavage begins in the periblast region also. The division of nuclei occurs rapidly. Division of nuclei occurs rapidly than that of cytoplasm. As a result, that extra nuclei make the periblast syncytial. The cells of the periblast lie over yolk, engulf and digest the yolk and form extra embryonic endoderm. In future, the activities of the periblast cells supply nourishment to the growing At this stage, the germinal disc or the blastodisc is divisible into a central translucent and clear area pellucida and a peripheral darker and opaque area opaca. Being separated from the yolk, being separated from the yolk through the segmentation or subgerminal cavity, the area pellucida appears translucent. Area opaca lies over the yolk and hence looks darker. The embryo is formed entirely within the area pellucida, while the area opaca is concerned with the digestion of yolk and the formation of extraembryonic membrane and blood vessels. Next stage, blastulation. With the formation of segmentation or subgerminal cavity, the developing embryo enters the blastula stage. The subgerminal cavity of the cheek is very commonly compared comparted with the blastocele of other vertebrates, and this stage of development is called the blastula. But according to Pastils, this cavity is not homologous. This cavity is not homologous to the blastocele. In fact, the subgerminal cavity is an area where solid yolk is liquefied with the help of certain enzymes secreted by the overlying cells of the blastoderm. About 12 to 14 hours after the egg reaches the uterus, 6 to 8 hours before the egg is laid, some cells, yolk-filled ones, of the lower layer of the 3 to 4 cells, thick blastoderm becomes detached from the blastoderm and move down by polyinvagination into the subgerminal cavity. Less yolky cells remain in the blastoderm. This shedding of the yolky cells from the blastoderm begins from the future posterior edge of the area pellucida and gradually spreads forward until entire area pellucida becomes free of yolky cells. As a result, the epithelial layers in the region of area pellucida becomes thinner, consist of fewer layers of cells. The yolky cells first form a thin layer in the subgerminal cavity. Soon this layer is joined by a sheet of cells which separates from the posterior marginal zone of the blastoderm. Thin layer is called hypoblast. It forms a complete layer below the blastoderm. The remaining part of the blastoderm is now called as epiblast. These two layers remain joined together at the margin of the area opaca. The space between the two layers is called the blastocele, and the space between the hypoblast and the yolk is now termed the subgerminal cavity. The hypoblast starts forming just before the egg is laid and is completed in the first hours after laying. E.L. Ziladi and Kochow in 1976, the yolky cells of the hypoblast appears to be resorbed later. However, the hypoblast contributes cells for the formation of some extraembryonic membrane, but none at all for the formation of the body of the embryo. Hypoblast induces the formation of primitive strict in the epiblast and determines its orientation. The epiblast later gives rise to all three germinal layers, ectoderm, mesoderm and endoderm of the embryo according to Pastils in 1945 and 1957. These two layers embryo represent the blastula or discoblast stage. This is the fertilization, cleavage and blastulation of chick embryo. Okay, thank you.